let's look at steps for solving rational inequalities. The beginning steps are going to be very similar to our rational equations. So factor denominator, find the domain. Then you're going to find the LCD and multiply every term by that LCD. You're going to simplify each fraction. The actual fractions should cancel out. Now, you're actually going to pretend that this is an equation. You can even replace our inequality symbol with an equal sign if you need to, and you're going to solve the resulting equation. Now, here's what's different. Those answers that you get from solving your equation aren't the answers. We need to make a number line and dividing that number line using the answers that we found by solving, as well as the answers of my excluded values. Once we have a number line with those numbers on it, we're going to have intervals where we find test points. And that's the tedious part that might take a little bit of time and that you want to be really careful with. So let's get going with an example so that you really understand these directions. First thing first, find that domain. This guy's the only one with our variable in our denominator, so that's x such that x can't equal positive 2. Now we find our LCD. The LCD, 3 and 4 is 12, so it's 12x minus 2. We're now going to multiply everything by our LCD. Our result there is going to be that the 3 and 12 cancel, so we're left with 4x times x minus 2 minus 12 is less than 12 and 4 will cancel, be left with 3 times x plus 1, x minus 2. Now, from here, we want to just simplify and combine our like terms. So this will give us 4x squared minus 8x minus 12. And we can even, like I said, pretend that this is just an equation right now. That's totally fine. This will give me 3x squared minus 3x minus 6. Now, move everything over to the left side. We'll have x squared minus 5x minus 6 equals 0. Solve that. That will give me x minus 6 and x plus 1. So we get x equals 6 and x equals negative 1. Now remember, these are not my answers. These are going to help me figure out the intervals for my answer. So we're going to take a number line and we're going to put our answers and excluded value on that number line. So we have a negative 1, we have a 2, and we have a 6. What you're going to now do is you're going to make test points in each interval. So we have values less than negative 1, we have values between negative 1 and 2, values between 2 and 6, and values greater than 6. So we're literally going to plug in some values. Now for time-wise, I'm just going to go through it quickly with you. But you'll want to plug in, every number and calculate it. So I'm going to first pick something less than negative 1. So I'm going to pick negative 3. You're actually going to plug negative 3 into the inequality up above. So I'll do this for the first one. Negative 3 over 3 minus 1 over negative 3 minus 2. And I want to know, is that less than negative 3 plus 1 over 4? And what you get is negative 4/5 is less than negative 1/2. And that is true because this is really close to negative 1 and this is negative 1/2. So the more negative we are, the smaller we are. So that is true. So what that's telling us is that one of my solutions is going to be that anything less than negative 1 will work. We're going to continue on by plugging in more test points. Okay, so we'll have a test point now between negative 1 and 2. I'll pick 0. That's very easy. When I plug 0 in, and again for time-wise and space-wise, I'm not going to show out every calculation, but when I plug 0 into my inequality, okay, we're going to simply just get 0 plus 1/2 is less than 1/4. And is 1/2 less than 1/4? No, that is false. So this will not be part of our solution. Now let's test between 2 and 6. So I'm going to test 4. So I'm going to plug 4 into my inequality, and what we get is 5/6 is less than 5/4. And is that true? Yes, that's true, right? This is less than 1, this is greater than 1. So that is true. What that's telling us is that our solution is between 2 and 6. Lastly, let's test something greater than 6. So let's test x equals 8. And you can pick anything. You can pick 100 if you want to, but just try to make things a little easy on yourself. So I'm going to take 8 and I'm going to plug it in to my original inequality. 8/3 and so forth. When I do that, we get 30/12 is less than 27/12. Is that true? No. So if we look at what we have done, and remember, these calculations may take a little bit of time, and that's okay. When I look at my answers here, I want to focus on the ones with the checks. So this guy worked, and this one worked. So my answer is going to be that x can be less than -1, or x is between 2 and 6. And there you have it. Okay, so any of the ones that you got true, that will be your solution. Now let's go look at number 7. And I did most of this out so we can walk through it, but you can give it a try. Find our domain. We just have x's, so x can't be 0. Our LCD is 9x. Multiply through. We have values cancel, so we're left with 12 plus 63 equals 5x. And that's going to tell us x equals 15. So now I make my number line with the solutions that I first get, as well as my domain. So 0 and 15 get placed on my number line. I now put test values in. So I'm going to pick something less than 0. I picked -1. And you can see I plugged in all of that and calculated. And that was true. I have a negative number is going to be less than a positive. So this was true. Put a check mark up here. Then I tested between 0 and 15. I plugged in a 1. That gave me 4/3 plus 7 is less than 5/9. Well, just looking at this is going to be over 8, right? And this is not even 1. So this is false. This number is not less than 5/9. So it's not between 0 and 15. And then I plugged something in greater than 15. So I plugged in 20. When I plugged in 20, I see here that I'm going to have 25/60ths. Well, that's less than 1/2, and this is greater than 1/2. So this is true. This is smaller than that. So here are the values that do work. So what does that mean as an inequality? That means my solution will be anything less than 0 or greater than 15. Okay, I'll zoom out here so that you can take a look at it and pause it.